insulation class referred to in National Electrical Code section 450.21b exception is indeed the temperature rating in degrees Celsius. Insulation classes are standardized by industry standards such as Institute of Electrical and Electronics Engineers Standard C57.12-1 and International Electrotechnical Commission Standard 60085. These standards define different classes of insulation materials based on their ability to withstand different operating temperatures. In the context of National Electrical Code 450.21b, the insulation class refers to the maximum allowable operating temperature of the transformer's insulation system. Transformers with an insulation class of 155 degrees Celsius or higher are designed to operate at high temperatures without degrading the insulation. By using transformers with an insulation class of 155 degrees Celsius or higher, the transformer room requirement can be waived because the high temperature rating indicates that the transformer is less likely to overheat and cause a fire. National Electrical Code section 450 covers transformers. It provides requirements for the installation of transformers including auto transformers and dry-type transformers. It covers items such as overcurrent protection, guarding, ventilation, and transformer rooms. National Electrical Code section 450.21 specifically addresses dry-type transformers installed indoors. Subsection B of 450.21 focuses on transformers rated over 112.5 kV. It states that these transformers must be installed in a transformer room of fire-resistant construction. The fire-resistant rating must be at least 1 IR. This is to contain a potential fire within the room and prevent it from spreading to other parts of the building. There is an exception to the transformer room requirement. This exception applies to enclosed dry-type transformers with ventilating openings. If the transformer has an insulation system that is rated 155 degrees Celsius or higher, a transformer room is not required. This exception recognizes that transformers with higher temperature insulation are designed to withstand higher operating temperatures without decreasing the risk of fire. The insulation class designation indicates the maximum temperature that the transformer's insulation can withstand without degradation. Common insulation classes include 105 degrees Celsius, 130 degrees Celsius, 155 degrees Celsius, 180 degrees Celsius, and 220 degrees Celsius. These classes are defined by standards such as Institute of Electrical and Electronics Engineers C57.12-1 and International Electrotechnical Commission 60085. These standards specify the materials, testing procedures, and performance requirements for each insulation class. The standards ensure that transformers are designed and manufactured with insulation systems that can reliably operate at their rated temperatures. For example, a transformer with an insulation class of 155 degrees Celsius is designed to operate continuously with a maximum conductor temperature of 155 degrees Celsius without causing damage to the insulation. The insulation system is designed to withstand this temperature without breaking down or losing its dielectric strength. If the transformer operates above its rated temperature, the insulation may degrade prematurely, leading to insulation failure and potential fire hazards. Therefore, it is important to select transformers with appropriate insulation classes for the intended application and operating conditions. When selecting a dry-type transformer for indoor installation, it is important to consider the ambient temperature and the load on the transformer. If the transformer is located in a high ambient temperature environment or is subjected to heavy loads, it may be necessary to select a transformer with a higher insulation class to ensure reliable operation and prevent overheating. In addition to the insulation class, it is also important to consider other factors such as the transformer's kVA rating, voltage rating, and impedance. These factors will affect the transformer's performance and suitability for the intended application. It is also important to ensure that the transformer is installed in accordance with all applicable codes and standards, including the National Electrical Code and any local building codes. This will help to ensure the safer and reliable operation of the transformer. Transformers are a critical component of electrical power distribution systems. They are used to step up or step down voltage levels to match the requirements of different electrical equipment and loads. Dry-type transformers are commonly used in commercial and industrial buildings because they are relatively safe, reliable, and require minimal maintenance. Dry-type transformers do not use oil or other liquid coolants. This eliminates the risk of oil leaks and spills. However, dry-type transformers can still pose a fire hazard if they are not properly designed, installed, and maintained. Overheating, insulation failure, and arcing can all lead to fires. Therefore, it is important to select transformers with appropriate safety features and to follow all applicable codes and standards for installation and maintenance. The National Electrical Code provides detailed requirements for the installation of transformers, including requirements for overcurrent protection, grounding, ventilation, and transformer rooms. These requirements are designed to minimize the risk of fire and electrical hazards. When installing a dry-type transformer indoors, it is important to ensure that the transformer is properly ventilated. Transformers generate heat during operation. If the heat is not properly dissipated, the transformer can overheat, leading to insulation failure and potential fire hazards. The National Electrical Code requires that transformers be installed with adequate ventilation to prevent overheating. The amount of ventilation required depends on the transformer's kVA rating and the ambient temperature. In some cases, it may be necessary to provide forced ventilation such as fans or air conditioners to ensure adequate cooling. It is also important to ensure that the transformer is properly grounded. Grounding provides a path for fault current to flow back to the source. This helps to protect personnel and equipment from electrical shock and fire hazards. The National Electrical Code requires that transformers be grounded in accordance with specific requirements. These requirements vary depending on the transformer's voltage rating and the type of grounding system used. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed when installing a transformer. These codes and standards may vary depending on the location and the type of facility. It is important to consult with a qualified electrical engineer or contractor to ensure that the installation meets all applicable requirements. Regular maintenance is essential to ensure the safe and reliable operation of transformers. Maintenance tasks include visual inspections, cleaning, and testing. Visual inspections should be performed regularly to check for signs of damage, overheating, or loose connections. The transformer should also be cleaned periodically to remove dust and dirt that can accumulate on the windings and other components. Testing should be performed periodically to verify the transformer's performance and identify any potential problems. Common tests include insulation resistance tests, turns ratio tests, and impedance tests. These tests can help to detect insulation degradation, winding faults, and other problems that could lead to transformer failure. If any problems are detected during maintenance, they should be corrected promptly to prevent further damage and ensure the safe operation of the transformer. Transformers are essential components of electrical power distribution systems. Proper selection, installation, and maintenance are critical to ensure their safe and reliable operation. By following the requirements of the National Electrical Code and other applicable codes and standards, you can minimize the risk of fire and electrical hazards and ensure the long-term performance of your transformers. The insulation class of a transformer is a critical parameter that determines its ability to withstand high operating temperatures without degradation. This is directly related to the transformer's safety and reliability, particularly in indoor installations. The National Electrical Code Section 450.21b provides specific guidelines for dry-type transformers installed indoors, emphasizing the importance of fire safety. Let's delve deeper into the significance of insulation classes, the standards that govern them, and the practical implications for transformer installations. As mentioned previously, insulation classes are standardized by industry bodies like the Institute of Electrical and Electronics Engineers and the International Electrotechnical Commission. These organizations have established rigorous testing and classification systems to ensure that insulation materials can reliably perform under specified thermal conditions. The insulation class designation, such as 155 degrees Celsius, indicates the maximum continuous operating temperature that the insulation can withstand without experiencing significant degradation in its electrical and mechanical properties. The Institute of Electrical and Electronics Engineers Standard C57.12.1 covers the general requirements for dry-type transformers, including insulation classes, temperature rise limits, and testing procedures. The International Electrotechnical Commission Standard 60085 provides a more comprehensive classification of insulation materials based on their thermal endurance. These standards define the different classes of insulation materials based on their composition, construction, and performance characteristics. The standards specify the test methods used to evaluate the thermal endurance of insulation materials. These test methods include accelerated aging tests, thermal cycling tests, and dielectric breakdown tests. The results of these tests are used to determine the insulation class of the material. The insulation class is then used to determine the maximum allowable operating temperature of the transformer. The choice of insulation class depends on the application and the expected operating conditions. For example, a transformer that is installed in a high ambient temperature environment or that is subjected to heavy loads may require a higher insulation class than a transformer that is installed in a cooler environment or that is subjected to lighter loads. When selecting a transformer, it is important to consider the insulation class and to ensure that it is appropriate for the intended application. The insulation class is typically marked on the transformer's nameplate. The nameplate also includes other important information about the transformer, such as its kVA rating, voltage rating, and impedance. The insulation class is an important factor to consider when selecting a transformer. However, it is not the only factor. Other factors, such as the kVA rating, voltage rating, and impedance, should also be considered. It is important to select a transformer that is appropriate for the intended application and that meets all applicable codes and standards. In the context of National Electrical Code 450.21b, the exception that allows enclosed dry-type transformers with ventilating openings to be installed without a transformer room if they have an insulation class of 155 degrees Celsius or higher is based on the understanding that these transformers are less likely to overheat and pose a fire risk. The higher temperature rating indicates that the insulation system is designed to withstand higher operating temperatures without degradation, reducing the likelihood of insulation failure and subsequent fire. However, it is crucial to note that even with a higher insulation class, proper ventilation and maintenance are still essential for safe and reliable operation. Transformers generate heat during operation. If the heat is not properly dissipated, the transformer can overheat, leading to insulation failure and potential fire hazards. The National Electrical Code requires that transformers be installed with adequate ventilation to prevent overheating. The amount of ventilation required depends on the transformer's kVA rating and the ambient temperature. In some cases, it may be necessary to provide forced ventilation such as fans or air conditioners to ensure adequate cooling. It is also important to ensure that the transformer is properly grounded. Grounding provides a path for fault current to flow back to the source. This helps to protect personnel and equipment from electrical shock and fire hazards. The National Electrical Code requires that transformers be grounded in accordance with specific requirements. These requirements vary depending on the transformer's voltage rating and the type of grounding system used. Regular maintenance is also important to ensure the safe and reliable operation of transformers. Maintenance tasks include visual inspections, cleaning, and testing. Visual inspections should be performed regularly to check for signs of damage, overheating, or loose connections. The transformer should also be cleaned periodically to remove dust and dirt that can accumulate on the windings and other components. Testing should be performed periodically to verify the transformer's performance and identify any potential problems. Common tests include insulation resistance tests, turns ratio tests, and impedance tests. These tests can help to detect insulation degradation, winding faults, and other problems that could lead to transformer failure. If any problems are detected during maintenance, they should be corrected promptly to prevent further damage and ensure the safe operation of the transformer. The requirements in the National Electrical Code are intended to protect people and property from the hazards associated with electricity. It is important to follow the requirements of the National Electrical Code and other applicable codes and standards to ensure the safe and reliable operation of electrical equipment. When dealing with electrical equipment, it is always best to consult with a qualified electrical engineer or contractor. A qualified professional can help you to select the right equipment for your application and to ensure that it is installed and maintained properly. Choosing the correct installation class for a transformer is a multifaceted decision that must consider the application, operating conditions, and applicable codes and standards. The aim is to ensure that the transformer operates safely and reliably for its intended lifespan while mitigating the risk of fire or other hazards. The higher the insulation class, the greater the transformer's ability to withstand high operating temperatures without degradation. This is why transformers with an insulation class of 155 degrees Celsius or higher are allowed to be installed without a dedicated transformer room, as specified in National Electrical Code 450.21b exception. However, it's important to reiterate that this exception does not eliminate the need for proper ventilation, grounding, and regular maintenance. These are essential safeguards that contribute to the overall safety and reliability of the transformer installation. Moreover, it is crucial to consult with qualified electrical engineers and adhere to all local codes and regulations to ensure compliance and safety. Transformers play a critical role in electrical power distribution systems. Selecting, installing, and maintaining them correctly are crucial for ensuring reliable and safe operation.